Welcome back to part 2 of the video lesson on section 8.2, the z-test for a mean. In part 1, we were working through this hypothesis testing example problem. We had gotten to step 2, compute the test value, and we had seen a couple different ways of doing that on the graphing calculator and on that special Excel spreadsheet that I put up for you. But if you want to compute this yourself, without any special help, that would involve taking these 4 numbers and plugging them into this formula. So let's see what that looks like. We're putting in 9.2 for x bar, 10 for mu, 1.4 for sigma, and 50 for n. So that would be parenthesis 9.2 minus 10, close parentheses, divided by parenthesis 1.4 divided by the square root of 50, close parentheses, and that comes up as negative 4.04. So that's the same number we got those other couple ways. So the test statistic is negative 4.04. Now on to step 3. Here's where we have to find the p-value. If you did this on the calculator, you put in the numbers, you asked it to calculate. Notice right below the z-score, it gives p equals. Now be careful. If you're not looking carefully, you might think that p is about 5.3. But look here. See this e minus 5 on the end? That means it gave you the p-value in scientific notation. It's really 5.3 something times 10 to the negative 5 power. So if you write that out normally, you take this decimal point and slide it 5 spaces over to the left, and the p-value written normally would be 0.000053, and so on. On that Excel spreadsheet we were looking at, it gives 3 possibilities for the p-value depending on what our alternative hypothesis looks like. Remember, we said that H1 was mu does not equal 10. And so it tells us that in that case, the p-value is 5.331 e negative 0.05. So again, that's the scientific notation. It means that really small number, 0.000533, and so on. Now, what if you don't have a graphing calculator or Excel or any special help like that? I told you you can do this using table E. So let me show you how that would work. Okay, remember we computed the test statistic, Z, and it came out to be negative 4.04. That is the Z value that I would look up on table E. So I'd look for where Z is negative 4.04, except the table doesn't really go back that far. The smallest, most negative Z on the table is negative 3.4 or something. So it doesn't go back any further than that. A Z of negative 4 point something is literally off the charts. So we're not going to be able to tell from the table exactly what the p-value is, but that's okay. We don't really have to know exactly what it is. What the table does tell us is that that p-value is really small. It's even smaller than what it would be for negative 3.4, which is 0.0003. So from the table, all we know for sure, and it's really all we need to know, is that the p-value is a very small number, smaller than 0.0003. If you remember, the calculator in the Excel spreadsheet gave us the number 0.00000533 and so on, which is indeed smaller than 0.0003. Okay, so now that we have the p-value, we can go on to step 4. Make the decision to reject or not reject the null hypothesis. So when we get to step 4, we always say one of two things. We either say reject the null hypothesis, or we say do not reject the null hypothesis. It's always just one or the other of those. How do we decide? We compare the p-value against the level of significance, alpha. And in all the examples we're going to be doing, it'll just tell you what number to use for alpha. Like here it says at alpha equals 0.01. So you'll be given the number to use for alpha. In the real world, alpha is usually either 0.05 or 0.01, but it could be anything, and it kind of depends on the circumstances, how sure you need to be about what you're testing. So in this case, the p-value that we got is less than the level of significance. And in that case, you do reject the null hypothesis. The p-value represents the probability that you could get results like this from your sample if the null hypothesis were true. So what's going on here is, if this null hypothesis were true, we'd only have like a 0.000053 probability of getting a sample mean that was this far away from 10 if the population mean really is 10. So because the probability is so low, that makes us think, yeah, I don't think the null hypothesis is true. We can't say for absolute sure that it's not true, but we can be pretty sure it isn't. So we can reject the null hypothesis. It's like we've proved beyond a reasonable doubt that the null hypothesis couldn't be true. So when the p-value is less than the level of significance, you reject the null hypothesis. When the p-value is greater than the level of significance, then you do not reject the null hypothesis. And make sure you use those exact words. Don't say accept or support or something like that. It's do not reject. So here we did reject the null hypothesis. Okay, on to step 5, where we say, what does that actually mean in this situation? We rejected the null hypothesis. The claim that we were testing was the null hypothesis, that mu equals 10. So when you reject the null hypothesis, there is enough evidence, and since we rejected the null hypothesis was the claim, that's what we just rejected. We rejected the claim. So there is enough evidence to reject the pizza maker's claim. Okay, I have enough time to start another example, but I might not get all the way through it. So I'm going to end this video here and devote part 3 just to going all the way through another example. See you then.